Welcome back, Math 1. So 1.D is simplifying expressions by dividing powers that have the same base, right? Now, your teacher probably talked about this idea of what canceling means. And, to review what it means is if I had something like 4 times 3 over 5 times 3, what we say is the 3's here cancel out, right? And when things cancel, think about this. What is 3 divided by 3 going to give me? 1, right? Or this would change to 1, and 4 times 1 is 4. Over 5 times 1 would be 5. Now, right, we canceled out the 3's, and we have 4/5 left over, right? So basically, what canceling means in math is, two factors cancel out to give you a quotient of 1. And when you multiply by 1, it doesn't change the value. So when we use this idea of canceling to reduce fractions, right? So say I wanted to reduce 15 over 20. So I have 15 over 20. I'm going to figure out what number goes into both 15 and 20 evenly, right? That number is 5. So I'm going to break this up into 3 times 5 over, this one's going to be 4 times 5. So now, since 3 and 5 are linked by multiplication and 4 and 5 are linked by multiplication, these 5's have the same base, so we can cancel them out to leave me with 3/4. And if you think about it, what is 5 divided by 5? 1. And 3 times 1 is 3. 4 times 1 is 4. So that's kind of the idea of canceling. And this idea carries over into simplifying these variable expressions with same bases, right? So when I look here, it says expand the numerator and denominator and use the canceling method to simplify the expression. So if I have x to the 12th, that means I can expand this to x times itself 12 times over x times itself 8 times in the denominator. And now when I cancel these out, if I look here, I can cancel x's out until I have no more x's in the numerator and denominator to cancel each other out. And what do I have left here? I have x times x times x times x, which could be written as x to the 4th. And if I look at the next one, right, I have 7a's in the numerator, I have 4 in the denominator, and when I go to cancel out, what do I have left? I can't cancel anymore. I have a to the 3rd. Well, when I look at this, what shortcut could we potentially use then, right? Well, the shortcut I could use is, what could I do with 12 and 8 to get 4, and what could I do with 7 and 4 to get 3? Well, can't I just go ahead and subtract to get x to the 4th? Couldn't I subtract to get a to the 3rd? Yes. So what the shortcut here is, basically go ahead and subtract the exponents. Now, I technically don't like that method. I like to use the canceling idea in my head. I have 7a's up top, 4 on bottom. 4 cancel out, 4 on the top. How many do I have left? 3 in the numerator. That's kind of how I like to look at it. Now, the power of a quotient property means if I have some quantity like this, everything in the parentheses has to get raised to that exponent on the outside. So we would say x to the power of m over y to the power of m. And if we combine this property with the one prior, right, we could basically say, a power to a power, I multiply the exponents. Power to a power, I multiply the exponents. So these two expressions are equivalent, and these two expressions are equivalent. So let's take a look here on how we would approach some of these problems. So right away in the first example, 2 and 3 are both going to get raised to the 4th power. 2 to the 4th and 3 to the 4th. And when I look at doing that, these are different bases, so I can't simplify them. But I know right away 2 to the 4th power would be 16. 3 to the 4th power would be 81. Now for number 2, to eliminate the possibility of big numbers, what I like to do is I look, my bases are the same, right? 3 and 3. So I can write it as 1 base of 3 and subtract the exponents. So that would be 3 to the 3rd. And now I could potentially simplify this to 3 times 3 times 3, which is going to be 27. Okay? Now, let's look at and start with easy ones and then work to more difficult ones. So right away here, right, x to the 10th to the 7th, right? All I'm going to do is I'm going to do it one of two ways. I can do x to the 10 minus 7, which will give me x to the 3rd, or I can cancel out the smallest number of exponents. So if I take 7 x's off the bottom, if I take 7 off the top, how many do I have left? 3. This is kind of the approach I like, to cancel out the smallest exponent. So I can take 8 off the bottom. If I take 8 off the top, right, I know y to the 13 minus 8 is going to give me y to the 5th. Okay? Example 5, right? So I know right away I could do this one of two ways. A to the 8 minus 5, B to the 9 minus 3, and C to the 5 minus 1. Remember, if there's no exponent, it's a 1. And that would give me A to the 3rd, B to the 6th, C to the 4th. Okay? Now, what I like to do personally is I like to go through and say 5 A's cancel off 5, so I have 3 left. 3 B's cancel off 3, which means I have 6 left. 1 C takes 1 off the top, leaves me with 4. Number 6 now. We're elevating the rigor here. So number 6, I'm going to take everything in here and raise it to the 2nd power. So 8 to the 2nd power over y to the 3rd to the 2nd power. 8 to the 2nd is 64. Y to the 3rd to the 2nd is y to the 3 times 2, which would be y to the 6th. Now, number 7, if I go ahead and I do this problem in here, right, 5 to the 4th is going to give me a real big number, and 15 to the 4th is going to be a real big number. If I can reduce this fraction first, both 5 and 15 can be divided by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So I'm going to read this problem now as 1x to the 3rd, y to the 4th, over 3, x to the 2nd, y, and this is all to the 4th power. In my second step, I'm going to just go ahead and raise everything to the 4th power. You know 1 to the 4th power is just 1. So x to the 3rd to the 4th, I'm going to multiply these exponents to get x to the 12th. Then that's going to be y to the 16th. Now 3 to the 4th, remember, is 3 times 3 times 3 times 3, which is 81. X to the 2nd to the 4th is x to the 8th, then y to the 4th. But now I have to go through the concept of reducing. So my final answer, I know I have 1 over 81. My x's, if I have 8 on bottom, 12 on top, I'm going to cancel 8 out. If I take 8 off the top, 12 minus 8 would be x to the 4th. Then I have, x to the 4th goes in the numerator. Sorry about that. So it would be x to the 4th up here. Then y to the 16th over y to the 4th. Take 4 off the bottom. If I take 4 off the top, 16 minus 4 is 12. And that would be my final answer. Okay. Here, when I have fractions, I'm going to put it over 1. And then I multiply the numerators together. It's going to give me y to the 12th over y to the 9th times 1 is y to the 9th. And this is going to give me y to the 12 minus 9, which is y to the third. And we are done. Now, 9 and 10 are really difficult problems, right? If you're at this level, you're doing okay. The first thing I want to do is raise everything in this quantity to the fourth power. And basically what I'm going to do when I'm multiplying these, this will all be my numerator. This will all be my denominator. So what I'm going to do is write this as x to the 12th, and that's going to be y to the 5 times 4 is 20, right? But then I'm not doing anything to this, so I'm going to rewrite x to the second, y to the fourth, and down here, x, y to the third. Now, before I go and divide, the first thing I'm going to do is in my numerator, right, I'm going to combine the like bases, and in the denominator. And in here, I'm going to add these exponents to get x to the 14th, y to the 4th, over, if I look, I have x on bottom, then y to the 20th, times y to the third. I'm going to add those exponents to get y to the 23rd. Now, this is probably not, didn't mean for this to happen, but I guess it's not a bad thing to show. When I have x to the 14th on top and x on the bottom, that x cancels this out to leave me with x to the 13th in my numerator. But if you look here, I have 4 y's on top, 23 on bottom. So I know I can eliminate all 4, and if I take 4 off the bottom, how many do I have left? 19. And y to the 19th goes on bottom. All right. And number 10. First thing I'm going to do is raise everything in here to the second power. So real quick, -3 to the second power is 9. So 9, x to the 10th, y to the 4th, z to the 18th. Remember, power to power, we multiply. Over x to the 2nd, y to the 6th. Now in the second one, I'm going to go ahead and raise everything here to the 3rd. And 4 to the 3rd power is 64. So times 64, x to the 3rd, y to the 6th, z to the 12th, over y to the 3rd, z to the 9th. Now, when I multiply across, right? When I multiply same bases across, 9 times 64 gives you 576. Now here, x to the 10th times x to the 3rd, I'm going to add those exponents to get 13. So here and here. Now, when I do y to the 4th, right? Y to the 4th times y to the 6th, right? That's going to give me y to the 4 plus 6 is 10. Then z to the 18th, z to the 12th, when I add those exponents, 12 plus 18 is going to give me 30. This is all over. When I start with x, it's just going to be x squared. Y to the 6th times y to the 3rd is y to the 9th. Then z to the 9th. So right away when I go to simplify this, right? 576, nothing reduces that. If I have 13 x's up top, 2 on bottom, I know I can cancel 2 out. How many do I have left up top? X to the 11th. 10 y's up top, 9 on bottom. I cancel all 9 out. If I take 9 off the top, how many do I have left? 1. So it's y to the 1st. If I have 30 z's up top, oops, excuse me, I didn't mean to do that. Right? If I have 30 z's up top and I have 9 z's on the bottom, cancel all 9 out. And if I take 9 off this, I have 21. So it would be z to the 21st. I have nothing in my denominator, so I can just circle my answer here. Go ahead, work on the practice problems, and let us know if you have any questions.